Hello there, I'm Jimmy Vegas, and this is how to make a racing and driving game in Unity 5, and welcome to episode 3. So this episode, we're going to stabilize the camera on our car, just so it doesn't go a little bit crazy when we are driving around. We'll complete this little test circuit that we've got going on, and we'll also start looking at a little bit of the environment, so we'll add a bit of scenery in there as well. So firstly, let's sort out the camera on our car. And if you recall, although it works quite well following the car, the biggest problem we have is that when we're driving along and we go over bumps in the road, the camera gets a little bit unsteady. It's not quite how you would expect a driving game to handle. So we need to create a little script which kind of stabilizes the camera. So we need to make a couple of modifications first off. So for now, unattach the main camera from the car. So we'll deal with that a little bit later. So what we need to do is need to add a cube to the car itself. So on this car in the hierarchy, right click on 3D object, and then click on cube. Next, what you need to do is bring this cube up just above your car. Now this cube will act as the object that our camera will be looking at any given time, rather than the car. So depending on what camera angle you would like, you could have your cube further up, further down, but I'll show you that a little bit later on as well. So next thing we need to do is we need to start a script. So down here where we have assets, let's right click, create a new folder, and I'm going to call this scripts. So every script that we write will go into this folder. So in this window now, right click, create, and click on C# script. And let's call this something that we can remember. So camera stable, or sable as I've called it. Let's F2 that and call it stable. So double click. It'll bring you into either MonoDevelop or Visual Studio. Now, you can use either program. Throughout the series, I'm going to be using MonoDevelop, but you can use Visual Studio. The scripting is going to be exactly the same, and you don't need to worry about it too much. So I'm going to explain a couple of things in this first. I'm not going to go into too much detail, but the first thing you'll notice is here where we have public class, it actually says camera sable, which was my spelling mistake first off. Now, that spelling mistake was a little cunning plan to show you how this here has to be the same as whatever the script is named as. If you write a script and the public class name isn't the same as what your script name is, the script will not work. So I'm going to leave as sable for now, and then I'll prove this little point to you later on after we've written the script. So here we have void start and void update. So void start is calling the script just once. As we want to call the script every single frame because we want the camera to be permanently stabilized, we would use void update. Void update allows the script to be called every frame that the game runs. So as you can see here, we have an open curly bracket and a closed curly bracket highlighted. This dictates that this section is all linked together. So if we get rid of them 3 lines there, we would see that we no longer have a void start, and everything within the public class and the void update would go here. So these little sections here, which are currently highlighted grey on MonoDevelop, are just notes. So whatever you type with a double slash at the beginning, that's a double forward slash, is just a note. The script doesn't run any part of that at all. So we can get rid of them really. So within a script, to do most things, you would need to define what are known as variables. Now, a variable is, think of it as a container which will contain some information of some kind. For example, a number, an object, or text, anything like that. In this particular script, we're going to have 4 variables. The first variable is going to be the car. The other 3 variables are going to be numbers. So to define a variable in C#, I always like to put public, and then we define what the variable is going to be. So in this case, it's going to be a game object because we're going to define the car. So game object. And then we call the game object something, or rather call the variable something. So we're going to call it the car. And then we end that line with a semicolon. So every line in a script in this case would end with a semicolon. So every line would either have to end with a semicolon, or in this case here, as you can see, open or close bracket. So the next variable we're going to do is going to be the x-axis for our car. I'll explain a little bit more about the axis in just a second, as it'll be a float number. A float is going to be a decimal number. So you can either have an integer, which is a whole number, or a float, which is a decimal. Now the way we're going to do this is going to be public, and then it's a lowercase f on float, and then we'll call it car x. And then remember the semicolon at the end to say that line is done. Next we'll do public float, and we're going to do the y. So in this case, car y, semicolon. And then the final one, you've probably guessed it by now, is going to be public float, and it's going to be car z, semicolon. So next thing we need to do is, now as we define these variables outside of our function, in this case the function is the update, make sure, in fact it doesn't really matter too much in some scripts where you define variables, but I generally like to declare them after the public class is opened, so here. So in void update, what we need to do is, firstly we need to make them variables here, specifically the floats, equal to an actual number that we can use. So car x is going to be equal to the Euler angles of our car. So the way this is going to work is we need to refer to this variable, which is the car, and then we need to access, I'll just go back to Unity and I'll click on the car. We need to access this little section here that says transform. Now, although it has a capital T, we'll be using a lowercase t because that's just how we access it via the script. So the car, and then we specify which component we want to access, in this case transform, and then dot, and then we need to define which kind of subcomponent we need to access. In this case it's rotation. However, rather than use rotation, we'll use Euler angles. It's pretty much the same thing, but the rotation statement can go a little bit funny, especially in C#. So it'll be Euler, E-U-L-E-R, and that's a lowercase e. And now we need an uppercase A, angles. And then we need to define which one, X, Y, or Z. So in this case, it's dot X, and then semicolon. So what we've done there is we've made the script access the car into transform, into the rotation, and then into the X. So whatever number is in this particular box here will now be defined in our car X variable. So then we'll do the same with the other two. Car Y equals the car dot transform dot Euler angles dot Y. And you're probably ahead of me now. Car Z equals the car dot transform dot Euler angles dot Z. Okay, so now we have defined which numbers go into which variable. So what we need to do now is make the camera only look at these particular variables, but slightly modified, because the way it works is we want this cube, this side of the cube, to be constantly facing us. As it stands now, this cube will turn with the car. Now, a good way of actually countering that is whatever is defined in, for example, the X or the Z rotation, you just need to subtract that. So I'll just give you a little example now. As we drive along, you can see that the cube turns just normally, like it's attached to the car itself. We want the cube to actually rotate in the opposite direction of the car's rotation, so it gives a stabilized view for the camera. And we can do that by transforming the cube itself. So we would transform the Euler angles of the cube, and we would have to do it in a 3D environment to make sure this works. In JavaScript, this is much easier. With C# it becomes a little bit more complicated, but it's just one of the little quirks that you have to deal with coding. There's always ways around things. And to do this, we do transform.Euler angles equals a new vector 3, and that's a capital V, open bracket, and now we need to make an inverse of the Y axis, or the Y rotation, I should say. So it will be car X minus car X. So basically the rotation is going the opposite of where the car's going. This keeps it straight on the X axis. So we now need comma. Now we don't need to do an inverse for the Y, because the Y we want it to go up and down. So all we would do there is car Y. And then comma. The last thing we'll do is we do need an inverse of the Z or Z axis. So we'll do car Z minus car Z. And then close bracket and semicolon. And then hold Control, press S to save your script, or you can go to File and Save. So everything we've typed here is contained within this void update. And everything we've typed in total is contained within the public class. You always have to make sure that everything is contained in scripting, because if it isn't, if you start putting code down here after the class has ended, then you'll get errors in Unity and the script won't work. So if we head back to Unity now, generally if you've done something wrong, if you head to console, you'll see a big red mark here saying something isn't right. But that is not necessarily always the case. As it stands now, our script looks okay. But remember that little typing error we did? It now says camera stable, but the public class is camera sable. So if we try attaching this script to an object, i.e. the cube, we get an error. So if this happens to you, just make sure that your class name and your script name are the same. So in this case, let's change our public class name to the correct one, which is stable. So now all we need to do is attach this camera stable script onto the cube. And as we do that, if we click on the cube itself, you'll notice over here in the inspector panel, in the components, we have that script attached as if it were a component. So what we can do now is define just the car. You can see the X, Y, and Z variables are still there, so we just need to define the car there. So drag and drop the car over here. It's as simple as that. It's just a case of holding down your mouse button on the car, dragging it over, and dropping here. That's the beauty of Unity. It's very graphical. It's coding involved, but it's easy to do things like this. Easy. So I'm going to save my project there, and I'm going to press play. So we should now be able to see that this cube will rotate inversely to what the car does. So this edge is always facing us. And it hasn't. That's nice. Okay, so let's double check we've got this right. So let's attach our camera to the cube. Now we should be able to see that the camera itself is facing directly at the car. Now although the cube did not look like it was turning because the camera was still, when we press play now, we can see things have changed. So everything looks like it's working just fine. So the cube itself is now acting as the object which our camera is looking at, and you can see now, as we're driving around, the camera is much more stable than it was previously. So if we drive at high speed and go flying off somewhere, you'll be able to see that the camera doesn't go upside down, it doesn't flip, it keeps everything in check. Now there are different ways of handling a camera's stability in driving games. You can see we have the camera sorted just fine there. There are different ways of handling camera stability, but I find this way to be the simplest and, quite frankly, easiest. I think it's a good opportunity for you to take this and maybe expand in several different ways. But remember what I said earlier about having different camera angles. Well, this particular cube itself is now the basis for our camera angle. So if we were to, for example, drag it way up high, we'd be able to see our camera follows the cube and we can't actually see the car anymore. So we can use this cube in the future for different camera angles. So I'm going to hold Control and press Z to undo that move. The final thing we'll want to do is remove the cube itself, but keep it there theoretically. To do that, all we need to do is click this little tick here on Mesh Renderer. Now you can see the little green outline of the cube, so it's still there, but we can see straight through it. So when we press play, it's as though the cube isn't there at all, and our camera is focused on the car. So that's a nice stable camera for us to work with. And as I said earlier, we're going to create a test track that we can do a lot of different things on. So I don't know how far you guys have gone, whether you've created much of a test track at the moment. I'm just going to go ahead, take a second just to bring this test track around while I talk to you about what we plan to do in the future with this series. So far we've worked on a couple of different things, and although there is a lot to learn in a game like this, as long as we get the basics down, it's so much easier to kind of work out where we're going. For example, now we have the camera stability on the car. You may be able to work out for yourselves how to bring in different camera angles. Camera angles is something we'll be doing, and we'll be doing it pretty soon, to be honest. I think we might do in the next episode, actually, or the episode after. So we'll be doing some GUI as well. GUI is quite important as it is basically your display for everything. So we'll be doing things like a timer, things like goal objectives, markers, things like that. I think in general the UI is referred to as the HUD or heads-up display in most games. So it's up to you what you guys call it. So I've created just a quick little track here. It's nothing too spectacular. Let me see. I think I'll smooth this. How high can I go? Paint height, there we go, we'll do that. So you guys have remembered how to do pretty much all the little things in Unity with the terrain, but there's still a bit more to do with terrains, which I'm going to go into in just a second. And then we can put our entire course into practice. So a terrain, as I said, is a very versatile piece of equipment, if you want to call it that. And there's loads of different things you can do with it. So what I'm going to do is down here in Assets, I'm going to create a new folder, and I'm going to call this Objects. And in here, I'm going to drag and drop this simple tree. It'll take just a second, so it is just a case of dragging and dropping into the project itself. So I'm going to go into this tree, and you'll see that there's already a tree in there. This little tree icon here represents an entire tree, and rather than having to place a tree one by one, which can get quite tedious, there is a nice little way that we can do it in Unity. If we have our terrain selected and click on the place trees icon, which is denoted by two little trees, you can click on edit trees, add tree, and then in that folder drag and drop that tree, much in the same way we dragged and dropped our car into our variable. And now click on add. So make sure you still have the terrain selected. We can play with these settings just here. So brush size obviously increases and decreases the brush size. Tree density increases how many trees are in the area specified. So if we have 33, less trees will appear in the blue circle here. If we have 80, a lot more trees will appear in this little blue circle. Random ticked means that the tree height will be randomized between these two heights. Now I generally like to bring it up a little to about there, so the tree height randomizes between very small and very large, so anywhere between there. Lock width to height is basically just locking the random width to the height. You don't want really weird looking thin trees and really weird fat trees. If you do, then just make sure that's unticked. Color variation is just simple color variation on the leaves and the trunk. So we'll leave this as 0.4 for now. Don't worry about these other settings here. We'll deal with them at a later date. So what we'll do is we'll just take our tree, and we can do that nice and simple. So we're quickly drawing trees into our map. So I'm going to hold Control, press Z to undo that. And I'm going to increase the brush size, but decrease the tree density to about 35. And have some trees there. And around the edge, maybe there. Okay, so now we have a little bit of environment. So let's press play. And let's have a quick drive around our brand new test track. It's always good to test things and see how they pan out. So as you can see there, the camera stability working absolute wonders for us. And there we go. So as we can see, we're really coming on with this now, and we're only in the third tutorial. We've learned quite a bit, and we already have, technically, a racing game. It's a lot of fun to really build these sort of games, and it's great to see where you guys come up with the ideas and you stretch beyond what I've taught you. So as I say in the last episode, if anyone has any videos or images they want to share, please do. I love seeing this kind of stuff. So next episode, we're going to look at some GUI, as I say, with maybe some score, a time, and possibly an objective of some kind. And maybe next episode or the episode after, we'll start looking at different camera angles. So yeah, until then, guys, you just keep building. Thanks very much for watching.